Good afternoon, students. Today we are going to discuss a new topic that is called polynomials. And if you see the topics what we are going to discuss in this unit are like this. First, we'll learn that what is polynomial. Second one, we'll learn about that motivation behind learning polynomial, that why we should learn polynomial. Number three is that we'll see that polynomial of one variable. Then you will see the zeros of a polynomial. Then we'll understand what is a remainder theorem. Then we will see that how to factorize polynomial and factorization of polynomial. And then finally, we will look into algebraic identities. Okay. So to start our discussion, so let's first understand what is polynomial. If you see, dear students, as you see in the screen, a polynomial is an algebraic expression consisting of variables. Okay, variables also known as indeterminants. We will discuss in details, and coefficients. So what is polynomial? Polynomial is an algebraic expression consisting of variables and coefficients that involves only with operation of addition, subtraction, multiplication, and non-negative integer exponents. Let me give an example so that things get simplified when you give example. For suppose we write one thing called 2x plus 3. 2x plus 3 is a polynomial. If you see, there is a variable called x, and this coefficient, you see 2 is a coefficient. Okay, and that involves the addition, subtraction, multiplication, and non-negative integer exponents, because that power of x is what? 1. Nothing is there means it is 1. So it is a polynomial. We need to note one point, that the values of the coefficient remains the same throughout a particular polynomial, but the values of the variables keeps changing. We will see all these things. Now, let us take some examples. As I was telling, more examples. 2x plus 3 is an example of a linear polynomial. Why linear? That will come after some time. Okay. Of one variable x, the variable x, 2 and 3 are the coefficient of x and x power 0 respectively. Because whatever you see 2x plus 3, that 2x plus 3 you can write like this, na? That 2x plus 3, what you see, let me use a different color. That 2x plus 3, you can write like that, 2 into x to the power 1 plus 3 into x to the power 0. So 2 and 3 are the coefficients. And what is the variable? Variable is x. Similarly, you will get another expression, something like this. 3x plus 7y is an example of linear polynomial. 3x plus 7y is an example of linear polynomial of two variables x and y, where 3 and 7 are the coefficients of x and y respectively. Here there are two variables, x and y. What we are going to discuss in the entire topic, as long as your class 9 is concerned, we will be discussing a linear polynomial. And may not be linear polynomial, it could be a quadratic polynomial or cubic polynomial, but it will be of one variable. Let us first see that what is a quadratic polynomial of one variable x. If you see 2x square plus root 3 into x plus root 5, 2x square plus root 3 into x plus root 5, this is a quadratic polynomial of one variable x. Why quadratic? Because the maximum power of x is 2 here. That is why it is a quadratic polynomial. And what are the coefficient of x square, x and x power 0 are 2, root 3 and 5. So if you see this thing, what we see here, 2x square plus root 3 into x plus root 3 into x plus root 5. Root 5 means what? Into x power 0, you can assume. So coefficient of, so maximum power of x is 2, that is why it is a quadratic polynomial. And what is the coefficient of x square? Coefficient of x square is 2. Coefficient of x is root 3 and coefficient of x power 0 is root 5. Now let's take another example. Suppose 2x square plus 3y square plus 16xy plus 5x plus root 3 into y plus 7. This is an example of a quadratic polynomial of two variables x and y. Why quadratic polynomial? Because the maximum power of x or y is 2. And why two variable? Because there are two variables x and y, two unknowns, that is two indeterminates. And what is the coefficient of x square? Coefficient of x square is 2, coefficient of y square is 3, coefficient of xy is 16, coefficient of x is 5, coefficient of y is root 3, and coefficient of the constant term, you can write, x power 0 or y power 0 or xy power 0. Okay, here it will be, xy power 0. It is actually 7. Now, this is what is called polynomial. I hope it is absolutely clear, dear students. If anything is not clear, never hesitate to let me know about it. Okay. Any real number is also a polynomial and literally known as a constant polynomial. Let me show you this thing. And dear students, at any point, at any moment, if you have any doubt, any smallest doubt, never hesitate to ask me. Okay? Never ever hesitate. So now what I was telling dear students is that any real number is also a polynomial and literally known as constant polynomial. For example, a real number. If we have a real number called 5, 5 is a polynomial. Okay. Okay, and it is a constant polynomial. How we can write 5 is equal to, it is the power of x is 0. We can write 5 into x to the power 0. No? That is also 5. So it is a constant polynomial. More specifically, the number 0 is called a zero polynomial. On the other hand, following algebraic expressions are not polynomial. For example, 2x plus 3 by x square is not a polynomial, as we can express 2x plus 3 by x square as 2x into 3 into x power minus 2. And see, the exponent of the second term is minus 2, which does not satisfy the condition of being a polynomial, as it is a negative exponent. If you go back to the definition of a polynomial, okay, what is that? A polynomial is an algebraic expression consisting of variables and coefficients that involves only in operation of addition, subtraction, multiplication, and non-negative integer exponent. Non-negative integer exponents. Very important. But when you see here in this example, what is the exponents of, x is minus 2 for the second term. As it is not non-negative, minus 2 is not non-negative, no? It is negative 1. Hence, it is not a, polynomial. Correct? Similarly, 3x square plus 4 into square root of x, or which we can say is that 3x square plus 4 into x to the power 1 by 2 is not a polynomial. As we see, the exponent of the second term is 1 by 2, which does not satisfy the condition of being a polynomial. Why? Again, the same thing. It has to be non-negative. Okay, got it? No, non-negative. As you see here, non-negative integer exponents. 1 by 2 is not an integer, hence it is not a polynomial. So, dear students, if I say, if we have something like that, ax square plus, not ax square, let me write ax to the power m plus, b into y to the power n plus c into xy to the power p. This will be a polynomial if m, n, and p are non-negative integers. Got it, no? If m, n, and p are non-negative integers, then we can say this is qualified to be a polynomial. Otherwise, it doesn't qualify to be a polynomial. Clear or not clear, dear students? I hope it is clear. Now, our point is that why we should learn polynomial. What is the reason that we should learn polynomial? There are few reasons, and we will discuss those. And after that, we'll come to our main discussion, that is the polynomial of one variable. So, as you see, dear students, polynomials appear in a wide variety of areas of mathematics and science. For example, they are used to form polynomial equations, which encode a wide range of problems, from elementary word problems to complicated problems in the sciences. So we will see there are word problems, real, real life problems which can be solved using polynomials equations. Okay. Second one is that is the first one, to form polynomial equations. For example, one polynomial equation could be something like this: 2x square plus 3x plus 7 equal to 0. That is a polynomial equation, and we can solve this polynomial equation. And the solution to the polynomial equation give us the the word problem for which we form this polynomial equation. It actually gives a solution to the word problem. We will see all these things later. But just understand that this is one of the objectives that why you should learn polynomial. That is to solve polynomial equations. Form polynomial equation and solve polynomial equations. Now, next one is that define polynomial functions which appear in settings ranging from basics, chemistry and physics, to economics and social science. Okay, so that is also another reason that why you should learn polynomial. Third one is that in calculus and numerical analysis to approximate other functions. That is little advanced topic. You will know later in your later classes that how in calculus and in numerical analysis, the polynomial is useful. In advanced mathematics, polynomials are used to construct polynomial rings and algebraic varieties, central concepts in algebra and algebraic geometry. These are all advanced topics and completely beyond your syllabus. But why I intentionally mention all these topics here is that unless you have your fundamentals very strong, you may not be able to understand this advanced concept later very clearly. That is why it is very important to understand the polynomial and polynomial functions and all these things and different terminologies around it very, very clearly. Okay, dear students, now what we are going to discuss is that we are going to discuss about the polynomial of one variable. What is polynomial of one variable? That we are going to discuss now. And that is the most important part in our discussion. First, I will give you an example because I strongly encourage in giving examples, because examples makes things, things, very understandable, and then we'll come back to the theory. So let's take an a general form first, and then we'll come back to this one. Okay. So let me first, let us first concentrate on some examples, and then we'll come back to the theory. Let's look into 3x plus 2. Okay. 3x plus 2 is a polynomial. Okay. And you see, if I write 3x plus 2 here, no, dear students, what is the highest power? Okay. That is called the, degree of a polynomial. Highest power of x is what? 1. So it is a polynomial of degree 1. And polynomial of degree 1 is also known as a linear polynomial. So 3x plus 2 is nothing but 3 into x power 1 plus 2. And the power of x is 1. And that is why it is linear. Now, when the power of x is 2, okay, that is called a quadratic polynomial. For example, as you see here in the next one, first one we discussed about linear polynomial. Second one is the quadratic polynomial. What is that? Here it is 2 into x square plus, let me write very clearly, 2 into x square plus 3x plus 2. If you look into it, this is a quadratic polynomial. Why? The maximum power of x is here 2. That is why it is a quadratic polynomial. Similarly, if we get a maximum power of x is 3, that is known as a cubic polynomial, which is look into the which is there in the next one, that is 5x cube. You see, 5x cube minus 7x square plus x plus 6, that's 5x cube. That is a cubic polynomial. Similarly, if the maximum power of x is 4, that is called as a biquadratic polynomial. What is that? X power 4 plus 2x square plus x plus 6. If you see, dear students, that maximum power of x is 4. That is why it is called a biquadratic polynomial. So let me recap quickly. So if the maximum power of variable, generally variable is denoted by x. Okay. If the maximum power of the unknown is 1, it is called a linear polynomial. If the maximum power of unknown is 2, it is called a quadratic polynomial. If the maximum power of x is 3, it is known as a cubic polynomial. If the maximum power of x is 4, it is known as a biquadratic polynomial. Now, the thing is that if you look into this particular case, that y square into x cube minus y into x square plus 3x plus 5. what we see, it is a polynomial of degree 3 in x and is called a cubic polynomial in x. The same polynomial we can say it is a polynomial of degree 2 in y. Why? Because the maximum power of y is 2 here and is called a quadratic polynomial in y. So the same expression what you see is that which involves both x and y, we can define it as a polynomial in x and polynomial in y also. When we say it is a polynomial in x, we should consider on what is the maximum power of x, which is 3. So we can say this is a polynomial in x of degree 3. At the same time, the same polynomial we can say in the polynomial of variable y with, degree 2, because the maximum power of y is 2 here. So what we see is that, depending on, the variable we are considering, we can say that what degree that polynomial is having. But in our class, in our, syllabus, we should be completely focused on the polynomial of, one variable, where the variable is only 1. So you understood, students? So what is meant by a polynomial now? Okay. And what is the degree of a polynomial? Okay. So, for example, if you give an, if I give an example, let me use a different color. Suppose I say that 5 into x cube plus 7x plus 8 is 8. This is a polynomial expression, and not only that, that is a cubic polynomial. Why? Because the maximum power of x is 3. Suppose if I say that, okay, we have a polynomial something like that, 11 into x square plus 15. Yes, that is a quadratic polynomial. Why? The power of x is 2. Suppose if I give a polynomial is called 3 into x to the power minus 2 plus 8, this is not a polynomial at all, because the power of x is minus 2, which is non-negative integer. Correct? So now, as we understood few examples here, now let us come back to discuss the actual definition of a polynomial. And what is the general form of a polynomial of one variable? What is that? A general form of a polynomial, a general form of one polynomial of one variable x is expressed something like this: an into x to the power n plus an minus 1 into x to the power n minus 1 plus an minus 2 into x to the power n minus 2. In that way, it will continue till a square into x square plus a1 into x plus a0. Now, where n is any natural number and ai for I equal to 0, 1, 2 up to n are real constants such that an is not equal to 0. What is n? N is any natural number, and ai means for I equal to 0, 1, 2 up to n are real constants such that an is not equal to 0. What is the degree of a polynomial then, dear students? We already discussed, but now let's discuss with a more formal definition. The degree of a polynomial is the highest power of the variable. For example, the above polynomial expression 1, is a degree is of degree n. Now, why it is of degree n? That whatever you see, that n should not be equal to 0. For example, if we take a polynomial, what the polynomial we take earlier is that 5x cube plus 7 into x plus 8. 5x cube plus 7 into x plus 8. Now, this is a polynomial expression of degree 3. We cannot say this is a polynomial expression of degree 4. Why? Because we can write this thing 0 into x to the power 4 plus 5 into x cube, but 0 should not be there. That is why an should not be equal to 0. What is the maximum power of n? That coefficient should not be equal to 0. I hope you got it, dear students, right? So the degree of a polynomial is the highest power of that one variable, okay, and that should not be equal to 0. Now, degree of a polynomial, we need to know 2 points. Degree of a constant polynomial is 0. What is a constant polynomial? 5 is a constant polynomial. Now, what is the degree? We can say this is degree 0. As I said few minutes back in today's class itself, we can write 5 into x to the power 0, no? So a constant polynomial having degree 0. The degree of a constant polynomial is 0. Now, degree of a 0 polynomial is not defined. These are the 2 points you should note. Correct, dear students? So what we discussed today? We discussed today so far is that, why we should, what is meant by, sorry, sorry. The first we learned is that what is polynomial. Then we understood about the motivation behind learning polynomial, that why you should learn polynomial. Third one is that polynomial of one variable. Okay, that what is that polynomial of one variable. Now, what we are going to learn, dear students, is the value of a polynomial. Okay, value of a polynomial, that we are going to learn now. 2 points we will learn now. It is the value of a polynomial and zeros of a polynomial. So dear students, generally a polynomial is denoted by fx. Okay, suppose you have a polynomial ax square. Suppose a polynomial you have 5x square plus 3x minus 7. As you know, dear students, this is a polynomial of degree 2 because the maximum power of x is 2 here. Now, as a symbolic representation, we define this as fx, gx, like this. So we define this as fx. So fx equal to 5x square plus 3x minus 7. So this is a polynomial. Now, what is the value of a polynomial? Value of a polynomial corresponding to the value of a x. Okay, for example, if we want to find the value of this polynomial at x equal to 2, what is the value of the polynomial? Value of this polynomial at x equal to 2, value of this polynomial fx at x equal to 2 is f2. Correct, no? So how to find the value of f2? The way we can find the value of f2 is equal to 5 into 2 to the power 2 plus 3 into 2 minus 7. So that implies what? That implies f2 equal to 2 into 2, 4, 4 into 5, that is equal to 20, plus 6 minus 7. That implies what we are going to get, dear students, f2 is equal to 19. So that is the value of the polynomial at x equal to 2. I hope you got a clear idea that what is meant by the value of a polynomial. So now let's concentrate on the left hand side theory. Let fx be a polynomial in x and alpha be any real number. The real number obtained by replacing x by alpha in each and every occurrence of x in fx is called the value of fx at x equal to alpha and is denoted by f alpha. For example, as you see here, fx equal to 5x square plus 3x minus 7, then the value of fx as x equal to minus 2 is obtained by applying minus 2 in each of the occurrence of this. So that is why 5 into minus 2 whole square plus 3 into minus 2 minus 7, and finally we get the value of f of minus 2 is equal to 7. And if you see in the right hand example, we have found the value of fx at x equal to 2. So that is called the value of a polynomial. So value of a polynomial at x equal to 2 is denoted by f2. What we got it as 19. Value of a polynomial at x equal to minus 2, that is equal to f of minus 2, which we find as 7. It may be possible that we can find the value of the polynomial at x equal to 0, that is 0. That should be what? 5 into 0 square plus 3 into 0 minus 7. That is nothing but minus 7. Correct, not dear students? So this is the way for any real number. See, x can be any real number. In the previous topic, we discussed about real numbers, and all the recorded lectures are there. I can share all the recorded lectures. Okay, it is available in YouTube. So you can follow this thing to recap your concepts in real numbers. So what I'm saying is that the value of a polynomial, that value of a polynomial is the value of this polynomial by replacing that particular value alpha here, what is actually mentioned. You see here we make that alpha sometime 2, sometime minus 2, sometime 0, and it can be any real number. So that is what is called the value of a polynomial. Now, as we understand what is the value of a polynomial, our next point what we are going to discuss is the zero of a polynomial. What is zero of a polynomial? That we are going to discuss now. What is zero of a polynomial? That the zero of a polynomial is that alpha. Okay, let me write down first, then we'll discuss. Okay. So, as you see, what is the zero of a polynomial? Let fx be a polynomial in x. A real number alpha will be said to be a zero of fx if f of alpha equal to 0. Let us understand. Let us understand by means of an example. Suppose we have a polynomial fx is equal to x square minus 3x plus 2. Now let us find the value of fx at x equal to 1. Okay, if we get that value of fx at x equal to 1 equal to 0, then we can say that 1 is a zero of that polynomial. Okay, for example, we are finding the value of fx at x equal to 1. What we are going to get? 1 square minus 3 into 1 plus 2, that is equal to 3 minus 3, that is equal to 0. So as we get f1 equal to 0, so what we can conclude? This implies 1 is a zero of fx, is a zero of the polynomial fx. Similarly, let's find the value of fx at x equal to 3. What is f3? So it should be 3 square minus 3 into 3 plus 2. That is equal to 9 minus 6 plus 2. That is equal to, it is 5, which is not equal to 0. That implies 3 is not a zero of the polynomial fx. That means what we understood? The zero of a polynomial means the value of x for which the value of the polynomial, entire polynomial, is going to be 0. Let's take another example. Let's find the value of fx at x equal to 2. What is the f2? It is 2 square minus 3 into 2 plus 2. That is equal to 4 minus 6 plus 2. That is equal to 0. So now what we can say, as we say f2 equal to 0, we can say that 2 is a 0 of the polynomial fx. 2 is a 0 of the polynomial fx. So now there is an obvious question. Sir, you can ask, sir, how many zeros of a polynomial is possible? That depends on that what is the degree. So if we get a polynomial of degree 2, we will have 2 zeros. What is the case here? If I use a different color pen. So fx equal to x square minus 3x plus 2 is a polynomial of degree 2. So it has 2 zeros. One zero is 1 and another 0 is 2. So similarly, if you get a polynomial of degree 3, then it can have at most 3 zeros. Okay. So why it is? Let me give an example. Suppose we take a polynomial. Let me use a different color. Suppose we get a polynomial of fx equal to x square minus 2x plus 1. Now let's find the value of f1. That is equal to 1 square minus 2 plus 1. That is equal to 0. That implies what? That implies 1 is a 0 of the polynomial fx. Now you will not able to find any other zeros of this polynomial despite the degree of this polynomial is 2. Okay. So what we can conclude? We can conclude a polynomial of degree n has at most n zeros. It can have either n zeros or less than that. You see here, in this case, fx equal to x square minus 3x plus 2, it has 2 zeros, 1 and 2. But you see this case, that fx equal to x square minus 2x plus 1, that polynomial is of degree 2. But we get only 1 0. You will never find another 0 apart from 1 for this polynomial x square minus 2x plus 1. So in fact, very correct statement I can write, 1 is the 0 of the polynomial instead of a. So suppose there is a polynomial of degree 3. So you can either have 3 zeros, 2 zeros or 1 0. Depending on what polynomial it is. Its degree is 3, but what type of polynomial? What are the different coefficients of the different terms of the polynomial? Clear, not dear students? So I repeat, a polynomial of degree n can have at most n zeros. That means a polynomial of degree 1 can have 1 0. A polynomial of degree 2 can have maximum 2 zeros. A polynomial of degree 3 can have maximum 3 zeros. A polynomial of degree 4 can have maximum 4 zeros and so on. Okay. So another example, if you see that fx equal to x square plus 3x plus 2, you can also compute the way I'm showing you also. Suppose there is a polynomial, what we bring here is that fx equal to x square plus 3x plus 2. Now what we can observe, let's find the value of this polynomial at x equal to minus 1 and x equal to minus 2. If you find the value of the polynomial x equal to minus 1 and x equal to minus 2, in both the cases, dear students, you will find the value is actually coming to 0. Okay, let me show you. You can also do, as I said, okay, that minus 1, we find the value of f of minus 1. if we find the value of f of minus 1, what we get? Minus 1 whole square plus 3 into minus 1 plus 2 is equal to 0. So minus 1 is a 0 of the polynomial. Similarly, minus 2, if we put x equal to minus 2, what we get? Minus 2 whole square plus 3 into minus 2 plus 2 is equal to 0. So minus 2 is also 0 of the polynomial. So, and it is a polynomial of degree 2, so it can have maximum of 2 zeros. One 0 is minus 1 and another 0 is minus 2. Correct, not dear students? So what I want to do, I would like to show you that how you can appear what are the different DPPs, that is called daily practice problem, as available in the online test platform at KonarClasses.com. And after that, you can appear those DPPs before we start our next class on Tuesday. So what I'm going to do, dear students, I'm going to stop sharing this screen, and I want to share another screen with you. Okay. I hope you are able to view the screen. Can someone please confirm that you are able to view the screen, KonarClasses website? Manishika or Ansu? You able to hear my voice clearly?
Yes.
Okay, great. So then you know what, you click into the login. I'll create your login, Ansu, and after that you go to that you enter your login and password. After that, what will happen, dear students? You come to the right online examination. After that, you give here polynomials, and you will see the polynomial set 1, set 2. So set 1 is there. View paper details and write this, and you need to start solving this problem. So I want you to appear 4 DPPs, okay, before we start our class. So Ansu, I'll explain you later how you can submit those DPPs, okay. And you need to submit before we start our next class. So you need to submit 4 DPPs, set 1, set 2, set 3, and set 4. Okay, so with this, I would like to conclude the class for today because there is not much discussion is there at this moment. So what you can spend time is that you open your respective notebooks, okay, in the next half an hour and go through whatever I just explained and look into the worked out problems. And after that, it will be good if you can appear 1 DPP, in another 1 hour or so. So with this, I would like to conclude the class, dear students here. If you have any specific comments, you can let me know. Otherwise, we can conclude. Okay, thank you very much.